Look at the rhythm of a normal day. We wake up, pay our bills, shop for groceries, and message our friends. Those basic human interactions rarely happen directly anymore. They are routed through a massive, invisible layer of digital infrastructure. And powering almost all of that underlying architecture is artificial intelligence. We are interacting with AI constantly. It processes our financial transactions and filters our daily communications, usually without us ever noticing it's there. Because it operates quietly in the background of almost everything we do, it exerts an enormous, quiet leverage over modern life. We find ourselves heavily dependent on complex systems that the average person cannot clearly see or explain. That creates friction. These models are evolving so quickly that the gap between what the machines can do and what the public understands gets wider by the day. Developing a functional system is only the first step. Without a method for building trust into these models, our total reliance on them remains a significant, unmanaged risk. Managing that risk requires a specific tool, a structured, problem-solving mindset. This flowchart illustrates the mindset. We map a specific malfunction back to its root causes. Next, downstream branches categorize the layers of impact, showing who is affected. Finally, intersecting solution nodes visualize how a proposed fix disrupts negative outcomes or creates new problems. This is the exact methodology industry professionals use to approach the black box of AI development. Safely navigating an AI-driven world relies completely on this rigorous mechanical deconstruction of impacts rather than reactive guesswork. But this framework has a strict limitation. You cannot analyze or solve problems within a system you do not understand. While machine learning algorithms iterate at incredible speeds, humans have to aggressively maintain their own continuous education just to keep pace. On a daily basis, that means investigating tools by gathering expert input, conducting hands-on research, and iterating through critical feedback. Maintaining a curious mindset and asking direct questions about a tool's logic provides the necessary oversight to catch errors before they scale. Intentionally empowering ourselves with new information is the only viable way to maintain human agency over technology that evolves by the second. Applying this problem-solving framework and continuous learning helps you achieve a highly practical target: AI ethics. This chart illustrates the first objective of ethical AI, climbing data points representing systems designed to maximize societal utility. But notice the boundary lines overlaying the graph. This second objective minimizes potential risks, creating strict constraint zones that keep technology out of high-risk areas. True AI ethics is a calculated, structural balance between driving innovation forward and rigorously constraining its capacity for harm. Trust in artificial intelligence is never an accident, and it is certainly not the default state of the technology. Safety is only achieved when human beings intentionally and methodically work to infuse those ethical constraints into every single layer of a system's design and development. Ethical AI is a deliberate, manufactured outcome that requires constant human vigilance to maintain. Technology's deep integration into our daily routines is a permanent reality now, and its pace will only accelerate. But that permanence doesn't have to be intimidating, provided we equip ourselves with the correct mental tools. Regardless of your career or walk of life, anyone can adopt a problem-solving mindset and a commitment to continuous learning to better understand the algorithms they interact with. An educated public capable of questioning and using technology with intent ensures these tools serve the needs of the many rather than the few.